Oh, my friends, welcome back to Dennis Simplifies. In today's video, we are going to go through LU decomposition with partial pivoting. So sit back, relax, and let's simplify. Compute the permutation matrix, the upper triangular matrix, and the lower triangular matrix from A equals 381520612. So we are supposed to find the permutation matrix, which is P, the upper triangular matrix U, and the lower triangular matrix from this A matrix we have been given. So we know the formula PA equals LU for partial pivoting. So PA equals LU, where P is the permutation matrix, A is the matrix A, L is the lower triangular matrix, and then U is the upper triangular matrix. Now the idea in partial pivoting is that taking Gaussian elimination method, where we use just any number as our pivot to make the A an upper triangular matrix. Partial pivoting kind of solves the problem where your pivot is actually 0 or a smaller number. So anytime you are making an element a pivot, you always make sure that that element has its lower values smaller than it. So that pivot must be bigger than all the numbers that are lower than it. So let's take A for instance. A is 3, 5, 6, 8, 2, 1, 1, 0, 12. So since we want to make this an upper triangular matrix, we want to make 5, 6, and 1 zeros. Now in this case, our pivot is 3, but then 3 is smaller than even the numbers below it. 5 and 6 are bigger than it. So in partial pivoting, what we want to do is that we want to make our pivots the bigger numbers. That is, the numbers below them should be bigger. Sorry, they should be bigger than the numbers below them. So we have to move this 6 to the top. But before we do that, let's look at how P looks like. So P equals 1, 0, 0, 0, 1, 0, and then 0, 0, 1. So that is the permutation matrix for P. Now, as I said earlier, we have to swap row 1 and then row 3 because you can see that the number 3 is smaller than 6. And we said that the pivots must be bigger than the numbers that are below it in the column. So we are going to swap row 1 and then row 3. So you see obtaining U, R1 and then R2. We are swapping the two of them. So when we swap R1 and R2, this is what we are going to get. Now, because we have swapped R1 and then R2, we must update P, which is this one. We must update. So P is keeping us in check anytime we swap the rows. So when we swap any row, we must update P. So how do we update P? With P2, whenever you swap, you also update it by swapping the same values in the P. So R1, we are going to swap R1 and R3 also in P. So as you can see, P equals 0, 0, 1, 0, 1, 0, and then 1, 0, 0 as the update. So I've also swapped row 1 and row 3 in P. So how do we make this 5 here 0? To make this 5 here 0, as I said, we are making it an upper triangular matrix. So you have to make the 5, 3, and 8, all these places zeros. So to make the 5 0, we are going to take the 5 minus 5 on 6 times R1. So if I take 5 minus 5 on 6 times 6, I'm going to get this 5 here to be 0. And I'm going to use this formula for all the elements in this row. Right? And then when I do that successfully, I'm going to get this. Now you can see that the 5 part has turned to 0. So then I move to the next element, which is 3. I have to make the 3 also 0. So I take R3 minus half R1. So R3 is 3. So 3 minus half R1, which is 6. I'm going to get the 3 portion to be what? To be 0. Alright. And I'm going to use the same formula for all the elements on that row. So on the row 3, I'm going to use this formula for all the elements here. Alright. So when I do that correctly, I'm going to get this. So 6, 1, 12, 0, 1 on 6, negative 10, 0, 15 on 2, and then negative 5. Now, since we have been able to make this portion 0, we have to make the 15 on 2 also 0 to obtain an upper triangular matrix. But you can see that on our second column, we have to use our second row as our pivot. That means we have to make the 7 on 6 the pivot. But you can see that 15 on 2 is bigger than 5 on 6. So what that means is that we have to swap row 2 and row 3. And remember, anytime you swap, you must also update P, right? So over here, we are going to update the P by swapping row 2 and then row 3, right? So we update P and then we get 001, 100, and then 010. So that's what we are going to do. We update it. Now, when we update the original U itself, this is what we had. So you can see over here that we have swapped the 15 on 2 and then the 7 on 6. So now how do I make the 7 on 6 part 0? So I'm going to take R3 minus 7 on 45 times R2. What do I mean? I mean 7 over 6 minus 7 over 45 times 15 on 2 here is going to get this place to be 0. But how did I get a 7 on 45? You can just do this. Take 7 on 6 minus a variable, say x. So 7 on 6 minus x times 15 on 2 equals 0. So when you do the computation, you get x to be 7 on 45. So this is how you do it to obtain here to be 0. So you're going to use this formula for all the elements on this row, and then you're going to obtain this. So you can see that we've been able to achieve our goal of making this portion 0, 0, and 0. And then this is our upper triangular measure. So this is going to be our U. So now that we have our U, we can obtain our L, right? Because we can take 5 on 6, neglect the negative sign as our one of our L values. 1 on 2, neglect negative sign as one of our L values. And then we take the last one, which is 7 on 45, neglect the negative sign, and then take it as one of our L values. So let's go there. So obtaining L, we know L is supposed to be in this form. It's a lower triangular matrix. Each trivial values are the lower part of its matrix. So obtaining L, we are going to take 5 on 6, neglect negative sign, and then put it here. You're going to take the 1 on 2, neglect negative sign, and put it over here. And then last, we take the 7 on 45 from the U here, and then put it over here. So we say this is our L. So you can see that we've been able to obtain our U, our L, and then our P. Remember, we were updating our P alongside. So you can see that PA equals LU finally is this. So when we do, so you can even verify by multiplying them, and then you realize that you're going to get your answer. Alright friends, so that's it for this video. Remember, the video is not about showing you pictures. It's about giving you an understanding of what we are doing in class. So with the partial pivot and the LD decomposition. If you have any question, leave it in the comment section. I am willing to reply. And then make sure you like and then you subscribe. Until next time, Apatia.